Okay, so at this point, when people have been introduced to the problems with power that many studies have, despair does often set in, because there's been a sort of tendency to just not discuss this as an issue, although occasionally papers do pop up in the literature pointing it out. But for many people, particularly if you're not very well resourced, the time and the resources to do an adequately powered study seem out of reach for many people. Um, Statisticians are actually on record. There's somewhere, I was trying to dig it out, but there's a paper by statisticians describing how people come to them and are in a state of sort of shock when told how underpowered their studies are. And then they come and try and bargain with them and sort of say, well, surely there must be something you can do about this. Or else they will say, well, actually, my effect size, I told you it was going to be 0.3, but I think it's going to be 1, and therefore we'll be all right, won't we? So there's a sort of modifying the effect size to fit the available resources. And then quite often people are aware that there's a problem, but they just decide to ignore it and say, well, I can't do anything about it. I can't actually increase my sample size realistically. I haven't got time. And they then sort of just go ahead anyway. But you could argue that that's actually unethical. I mean, it depends on what sort of studies you're doing, but you know, if you're working with patients, you are just really wasting their time and possibly doing a study that will imply that there's no effect when there's a real effect. If you're working with animals, there's a lot of pressure to have small sample sizes, but I think the other thing that's now recognized is that if you only emphasize small sample sizes, it's actually less ethical, because you end up doing studies that are meaningless than it would be to use more animals and do a study that would actually give a convincing result. And if you're just working as a psychologist with members of the public, you know, you just don't really want to waste people's time, and you're wasting also any funding, grant money that you've got, and possibly just, you know, producing a literature that's not going to be very helpful. So it's a big problem, and it scares people when they find out about it. It's been going on for years. In the 1980s, this Newcomb, a statistician, wrote an article. He was talking about publication bias and how null results tend not to get published. But he also said that people have these small studies with a little more than a blind hope of showing the desired effect. And that was in the 1980s. And I think in the field of clinical trials, that's no longer the case, because it has been recognized that this is very bad for medical practice if you run these small studies that are inconclusive and don't really show you one way or the other whether there's anything going on. But for the rest of us, I think a lot of studies have just carried on. And so we have to think very hard about how we're going to deal with this. One possibility is to just say, P's at less than 0.05 is too stringent. Maybe we should make it less stringent and have another alpha level. You can boost your power a bit that way, but it doesn't have a huge impact unless you really relax alpha very substantially. And of course, it then means you'll get more false positives. There's always this trade-off between false positives and false negatives. So the more relaxed your alpha, the more false positives you get, but the more likely you are to see the true results. So there may be situations where you could do that, but it's not very often a very satisfactory solution. An alternative is collaborative studies to increase the sample size. And this has become much more routine in two fields that I know of, both clinical trials and genetics, where it was just been recognized that we were going nowhere fast with a lot of small studies, and we needed really big studies in order to get convincing results. It's going against the grain for many people, because we're sort of often encouraged to be highly competitive and not to collaborate, and to be also highly original. We mustn't just sort of do something that everybody else is doing. But I think that it's becoming increasingly clear that it's just how wasteful it is to work only in that sort of way, and that there are real benefits from doing collaborative studies. This logo here is to the Psychological Science Accelerator, which was one thing that developed out of discussions about this. And it's worth looking at their website, because they take the view that we can do globally distributed research and get really large sample sizes to answer some of the questions that have been uncertain, or whether the literature has failed to replicate. And one of the advantages is you can get big sample size. The other thing that is an advantage is that you can start to involve people from all over the world and make the science much less just focused in one or two well-endowed labs. So this can help with training of people in other countries, or getting insights from people in other countries about effects that may be rather non-generalizable to, say, other cultures. But of course, it takes a lot of organization, and it's a big move. But there is a view that this should be done more. And in student projects, there's Kate Button at the University of Bath has been making the case in psychology for group projects where where a group of students come together and they can each have a little sort of aspect of the project that is their own to write up. But they are really gathering communal data to, again, have enough data to say something sensible. But you can increase power without changing your sample size. So it's that's often not recognized, that there's more you can do. And this just has to do with thinking more about your measures and your experimental design. If you think back to session 1, at the beginning, I said we can think of, when we do research, we're trying to see a signal in noise, basically. And if we can reduce the noise, we've got a better chance of seeing the signal. And the obvious way to reduce noise that really follows on from everything I've been saying is bigger samples, because then you get a more precise estimate of whatever effect you're looking at. But the other options, which I'll go through in the next few blocks, are optimizing your design. And I'll just illustrate that with going from between subjects to within subjects design as a way of improving your power. And things like use of covariates can also have that effect. Just getting more data for each observation also can improve power quite markedly, but it will depend on exactly what you're doing and what the design is. And then having better experimental control of your dependent variables and checking that they are reliable gets really important, particularly for some kinds of observational design. So there's no script for this session. It's just a case of thinking about your own research area. Is statistical power a common problem in your area? Maybe not. Maybe you work with very, very large samples. But if it is a problem, what could you do about it? Would it make sense to adopt a more lenient alpha level? And you might want to simulate data to see how far that would give you an unacceptable rate of false positives, or whether you think it would be preferable to missing true effects. Would it be feasible for you to collaborate with other groups? Often this is not even thought about, but what would be the advantages and disadvantages? So I think these are all issues to ponder, and which we could definitely discuss further in the online session, interactive session that we're going to have at the end of the course. But for now, that's just some questions left for you to think about, and I'll stop sharing, and we can then think about the next